We've developed a lot of tools for thinking about right triangles. However, it turns out a lot of triangles are actually not right triangles. But whenever we look at a non-right triangle, we can always split the triangle up into two right triangles. And then we can use what we know about right triangles to think about this other triangle that is not a right triangle. So for example, consider this triangle I have shown here. Certainly not a right triangle, but we know two side lengths. One of them is 1.7 centimeters. One of them is 1.065 centimeters, and then we don't know the length of the other side. And then we have interior angle measures of 0.4 radians and 0.671 radians, and then we don't have this other interior angle measure, although we could find that value. So when looking at this triangle, if we wanted to know the length of this other side that we don't know the length of, we can actually take this non-right triangle and split it into two right triangles. We'll draw a line right down it right there. And now what we have is two right triangles. So we basically just split this thing up into two right triangles. So I'll actually kind of shade in what these right triangles look like. So we have this one right here. And then we have the other one that's over here on the right-hand side. So when we take those two right triangles and smush them together, we get back the original non-right triangle. So thinking about this just at a high level, if we knew the length of the horizontal side of this left-hand right triangle, and we know the horizontal length for this right side right triangle, if we knew both of those lengths, then we could add them together to actually determine the total length of the bottom of that larger triangle. So if we kind of draw this green left-hand side right triangle, if we redraw that, then what we can do is use our tools of trigonometry to determine that this horizontal side of this green triangle is 1.7 times cosine of 0.4 centimeters long. Now with the red triangle over here, the right triangle on the right-hand side, we can redraw that. I'll redraw it and put it in standard orientation. Okay, so I redrew that in standard orientation. It's not necessarily to scale, but we can use the tools of trigonometry to determine this horizontal side length, in which case it is 1.065 times cosine of 0.671 radians, and that'll tell us that horizontal side length. So if we add together these two horizontal side lengths, that should give us this total side length that we're looking for. And therefore, the horizontal side length for this original triangle is actually 1.7 times cosine of 0.4 plus 1.065 times cosine of 0.671. If we were to compute that value, that would give us this missing length that we're looking for. So even though we're dealing with a non-right triangle, we can split it up into two right triangles, use what we know about right triangles to determine some missing information, and then put together that missing information in a productive way.